Okay class, since we are done with cell wall synthesis inhibitor on the first video, let's proceed now with chapter 44, or the protein synthesis inhibitors agent, specifically your tetracycline, macrolides, clindamycin, chloramphenicol streptogramins, and also oxazolidinone. So we are expecting here class that it is now acting on the protein synthesis, not on the cell wall like the first video. So again, this is your chapter 44 of your CatZone. You can read your second portion of your SAS 8 and also the chapter 44 of CatZone as another information that you can get. So again, for the sake of only this video, we will only have the summary in order for you to have a guide lang. Okay? So you still have to read your SAS and also your CatZone because I'm not gonna tackle everything here because of the limited time also. So here is our objective class. So review on protein synthesis in bacteria. I think you are already quite familiar with this one, especially the central dogma on your biochemistry is very important in this topic. Also with your microbiology regarding your ribosomal subunits. So we will meet that one again. Next is to know the drugs under protein synthesis inhibitors, in which you already met them in the title itself, and then understand their mechanism of action and what bacterial diseases they can treat or manage. So we have here class, right here we have your ribosome. Ribosome within prokaryotic cell or bacterial cells especially are actually made up of two different subunits. So we have what you call your 50S, which is the large ribosomal subunit, and then down here you have what you call 30S ribosomal subunit. Anyway class, when we say 50S, 30S, what is the S sign here? What is the meaning of that? Okay class, that is not a subunit ha. Huwag kayong gumaya sa akin na I thought before ning-graduate na lang ko nga dili din na siya subunit, but rather Sydberg. During review na sad nako siya nahibawaan nga Sydberg din na ang meaning sa iyahang S. Okay, again, that is your 50S and 30S. So we have two ribosomal subunit, the 50S for the large and 30S for the small subunit. Okay class, this is only true for your prokaryotic cells, like your bacteria. But if for example, like our cells class, human cells is a eukaryotic, right? So we also have different subunit or Sydberg with regards to large and also the small. So for the large, we have the 60S, and then for the small, we have 40S as eukaryotic cell. Okay, the reason why I mentioned this because certain drugs attack the 50S rather than the 30S, or certain drugs attack the 30S rather than the 50S. Okay, so in order for us to have a brief overview ng class, we have here the mRNA. Okay, mRNA kanang murag kanang lain-lain og color, that is your mRNA. We also have here your tRNA. And then in your large subunit class, we have your A site, the P site, and E site. It is very important class. It is because your tRNA, this is where it comes in. It comes in your 50S. It's now be able to transcript the specific codon for its amino acid. Still remember the central dogma on the formation of your DNA and RNA, diba? Forming your protein synthesis, it is very important that the transcription itself, the pinaka first in the central dogma, dapat insakto siya, or else once there would be a modified protein, dali na siya maguba, or it will be abnormal, causing the cell to be, or causing the protein to be either destroyed, pwedeng dali na siya maguba or mamatay. Okay, so that is actually the main focus of your protein synthesis inhibitor. So actually, they are just either inhibiting the 50S or the 30S para ang protein is not be able to form. Okay? So like here class, So if you can see in the GIF class, so once your tRNA can go to your large subunit, so it is where now, or it is the time now in where your protein will be synthesized. Without this function class, your protein cannot be synthesized. Okay? Again, musulod ra siya sa large subunit. After musulod sa large subunit, then the protein is made. Okay, the first drug that we were gonna discuss is your tetracyclines. Your tetracyclines are considered to be a class of broad-spectrum antibiotics that act as bacterial protein inhibitors. So, example of them are your tetracycline, doxycycline, minocycline, and tigecycline. So, it's very easy to memorize them because of their ending, which is cycline. For their MOA, so it's basically class, your tetracycline binds to 30S ribosomal subunit, and by binding to 30S ribosomal subunit, it actually blocks the tRNA binding to 30S ribosomal subunit to actually bring your amino acid. So again, remember class that tRNA is actually bringing your amino acid to the ribosomes, right? So by blocking this process, is only act as a bacteriostatic and not a bactericidal. So it inhibits the growth of bacteria and not killing the bacteria itself. Again, your tetracycline is basically binding to your 30S subunit. Thus, by binding this class, it will now block your tRNA from binding to your mRNA. So if it cannot bind class, ang tendency is walay protein nga mahimo, or the translation for your protein synthesis is different na, causing it to disrupt or inhibit the growth of the bacteria. So again, for the MOA class, your tetracycline is considered to be bacteriostatic and not a bactericidal like your cell wall synthesis inhibitors. So again, it binds to your 30S subunits. Once it binds to your 30S subunit, it now blocks your tRNA from binding your mRNA. So in that sense class, walay protein nga mahimo, causing to inhibit the growth of your bacteria and not actually killing the bacteria itself. For the treatment class, it can treat your gram-positive and gram-negative aerobes, but they have limited use in anaerobes. It is also used in the, again, it can also use in the Borrelia burgdorferi, which is the one responsible for your Lyme disease, in which these bacteria that express your protein antigens, which is caused the disease, the Lyme disease. Okay, they also be able to treat your chlamydia. They also can treat acne in some sense, and also rickettsia. We also have your treating the Yersinia pestis, in which the one responsible for your bubonic plague disease. And then we also have your anthrax and pneumonia causing by specifically the Mycoplasma pneumoniae. So specifically class, each of the agent or each of the medication under your tetracyclines has different or specific treatment. So for example, tetracycline is considered to be the one responsible in treating your H. pylori. If you can still remember in our gastrointestinal tract na mga medications, in the quaternary nga medication, we have their tetracycline, right? It actually treats your H. pylori, in which the one responsible in the peptic ulcer. You also have your doxycycline. Doxycycline can treat your Lyme disease, and amoebiasis, and also prevention for malaria. your minocycline is the one responsible in treating your meningococcal carrier state, and also the cloxycline, it actually treats your renal responsible antidiuretic hormone. Tigecycline is for MRSA. Now let's proceed with aminoglycoside. Aminoglycoside actually class is been discussed in chapter 45. Pero ako na lang siya gi-appeal because its action is like your tetracycline. Why? Because this drug is also targeting your 30S subunits. So this aminoglycoside class, we have example here is your gentamicin, tobramycin, streptomycin, and other aminoglycoside which are really good at being able to specifically target the 30S subunit. T class, the tRNA is specifically carrying the anticodon, right, which is complementary to the codon with an mRNA. Okay, class, you see here, class, there is a tRNA. Your tRNA is specifically carrying the anticodon, which is complementary to the codon with an mRNA. So, and then they're carrying a specific amino acid, right? That specific acid to those codons. So, now when the RNA is coming to the A site class, again class, your there's ribosomal subunit, review lang natin, it has different site. We have the A site, the P site, and also the E site. So, guess what these aminoglycosides do? They cling in your 30S or 30S subunits, and then they block off this site, making tRNA not gonna enter to A site. If it's blocked the tRNA from being able to come into the A site class, can you be able to make a functional protein? No. Imagine it's blocking this tRNA, which is carrying the amino acid, the building block for proteins. If you inhibit the tRNA from coming in A site and allowing this protein to be elongated and made, then you're not going to be able to offer this bacteria to survive eventually. Okay? Aminoglycosides are weird because they are actually bactericidal. If you can still remember your tetracycline, which is bacteriostatic, aminoglycoside is bactericidal, though they are functioning in both in the 30S, but aminoglycoside is bactericidal while your tetracycline is bacteriostatic. Why? Aminoglycoside main function is not able for the bacteria to survive, while your tetracycline is only the protein or the bacterial growth. Okay? Let's proceed now with different site of action class in the protein synthesis inhibitor, which is your 50S. We have first your macrolides. Macrolides example are your erythromycin, clarithromycin, azithromycin, and ketolides. So, what are these agents are specifically doing? What they do is, they actually attack 50S ribosomal subunit. So, what happens is that the tRNA will come in, right? If you can still remember the one of the moving picture that I have seen, you have seen earlier, your tRNA needs to come inside your 50S, right? And then once it come in the site, which is your, still remember, your A site, your P site, and then the E site, what happens is that your macrolides come over, and as ribosome is actually moves across the mRNA, what it does is ribosome actually moves along the mRNA and synthesize the protein. What is this macrolide do is, they inhibit the ribosome from actually moving in elongation. So, instead of move siya para maka-form siya o large protein, dili siya maka-move because of macrolides. So, in this sense class, the peptide chain is inhibited from reading or moving along the mRNA. If they inhibit it from moving along the mRNA, then what is going to do? It's not gonna be able to synthesize a functional protein. If it can't synthesize a functional protein class, this could actually cause a lot of different problems. It's not bactericidal but bacteriostatic, meaning it actually inhibits the type of cellular function that doesn't result or doesn't cause the cell to die but inhibits certain pathway from functioning. Thus, your macrolide is bacteriostatic, preventing the ribosomes from moving along the mRNA and translating the actual mRNA to make protein. Okay? Your macrolides are really good at being able to treat your pneumonia, especially your Legionella or your Mycoplasma. They can also treat peptic ulcer disease. A specific bacteria for that is your H. pylori. It is also used or be able to treat a certain type of gastrointestinal infection caused by your Campylobacter. It can also treat your sexually transmitted disease caused by your chlamydia and gonorrhea. For the adverse drug reaction, we have GI disturbance, jaundice, and ototoxicity. Specific lang, your erythromycin is active against the same organism as your PenG. Azithromycin absorption is impeded by food. Thus, in taking your azithromycin class, it is also advisable for the patient that they would take it 1 hour before or 2 hours after each meal. Let's proceed now with clindamycin. Clindamycin acts same as your erythromycin. Since it acts the same with your erythromycin, we are expecting that your clindamycin is acting in what subunit? 50 or 30? Okay, very good. That is 50 subunit. It's gonna treat your fatal pseudomembranous colitis, your Bacteroides fragilis, or the infections associated with trauma, and your MRSA. Let's proceed now with streptogramins. Streptogramins, example of that is your quinopristine or dalfopristin. It can treat your reserve for vancomycin resistant Enterococcus faecium or your VRE. Next, it is also can treat your active against gram-positive cocci, including those resistant to other antibiotics, including your MRSA. Also, primary use for treatment of E. faecium infection plus VRE strain. Lastly, class, we have oxazolidinones. Oxazolidinones are your linezolid. I think that is wrong spelling. Linezolid, tanawan na lang sa libro. What is the spelling of that? Your linezolid class is actually the last agent for antibiotic. Why? Actually, class, during sa ako ang internship before in the community, we are fan of kanang searching with regards to the prices. So, it happened that we are assigned in the RX area or the prescription area, and then we found this drug linezolid in the brand name Zyvox. So we just accidentally typed in what is the price of Zyvox, and then we are shocked. Why? Because it costs actually each tablet, a 600 milligram tablet is actually costing 4,000 each. And then we also search on the syrup, and its cost actually 20,000. So we asked the pharmacist there, because we are just interns, so we asked the pharmacist on what medication this is actually for. So she said that it is used for those bedridden na nga mga patients. So meaning, class, if wala na ilaing medication, linezolid na ang ilahang ihatag. So this is your last choice. If we will have, or the patient will have a resistant for antibiotic, which is linezolid class, as of the moment, wala, or as of the moment, ongoing pa ang mas isog niya nga medication. So, it is very important, class, to take your antibiotics religiously because of this cost of medications. Aside from the cost of the medications, class, what if the last strain of our antibiotics will no longer be active in your specific patient? Okay, that's it.